In this short video, I'll discuss the following topics. Topic number 1, draw chi-square density distribution. Topic number 2, several Excel functions related to chi-square. Topic number 3, the first example from the textbook. Topic number 4, what is the Benford Law? Topic number 5, do those 23 receipts follow the Benford Law? Topic number 1, so let's draw a chi-square density distribution. Okay. And so we have x value, and also we have chi-square value. Okay. Because chi-square depends on the degree of freedom. Okay, so let's assume n equals 10. N equals 10. Okay, so 0, 1. So let's have like some x column. Okay, so this is chi-square. Okay, CHISQ-DIST. So this is density function. We have x value and degree of freedom. So let's assume it's n minus 1 and false, because we are interested in density instead of the cumulative density. Okay. Then we copy, we have to log the degree of freedom. Sorry, n. Then we copy and paste. Okay. So let's draw the graph. We highlight x and y, click insert, click recommended, then click OK. So this is chi-square density distribution. It is different from normal and student t. From this graph, you see it starts from 0 and to positive infinity. Let's do one in-class exercise. So type .ICE. So we're going to do this for the A, Scott's marketing. Okay, so this is, we enter for the A. Using the historical market share, we have multiple multinomial probability distribution with PA. So probability for A is 30%, probability B is 50%, and C is 20%. So we have these historical, or we can call it theoretical values. Okay. Scott Marketing Research conduct a sample study using a consumer panel of 200 customers. Okay. So we have a data set with 200 observations. Okay. Then we can calculate corresponding probability PA, PB, and PC. So we are going to test whether have the same result or not. Okay, so alpha is 5%, and so this is our hypothesis. Okay. And there are 3 ways to get the data. So method 1, method 2, method 3, and method 4. So if you are not taking my course, then you can just copy this line into your browser and get a result. Okay, so .A, so this is Scott. Okay, so data ID is 201, so .B 201. Then we are going to copy and paste to Excel. Okay, and so this is hypothesis. I'm going to paste our data here. Okay. Okay, so this is and so this is total. So let's look at, I'm going to make it bigger. Okay, so this is total. Summation. Okay, it's 200. Okay, so this is, I'm going to copy the Okay, so this is our calculated result. Okay, so this is probability. Okay, probability, and for first one we know it's 30%, and the second one is 50%. We simply type. The last one will be 20%. Okay, so this is count 48, 98, and 5. Okay, so let's look at the count. And so this is called expect. So this is expect count. Okay, the total is 200, 30%. Okay, so this is times total. Okay, 30% times 200. Okay, 60. So this expect value is 60. Okay, before we copy paste, we hit F4 to log our result. Okay, put this down. So this one down. Okay, and similarly we can get all the other result. Okay, and so this is our observed, and so this is our expected. Okay, observed, expected. So according to this formula, okay, so this is 1. So for the A, so let's calculate. I can just copy. Okay, so this is our observed minus expected. Okay, the power is 2 divided by expected. Okay, I'm going to use show formula. Again, we can treat this one as error term. Okay, so error squared divided by expected. Okay, then I'm going to copy these 2 and 2. Okay, so this is first difference squared divided by expected, second difference squared divided by expected, third difference squared divided by expected. The total will be our chi-square. Okay, chi-square will be summation. Okay, this is our summation. Okay, summation, I'm going to show the formula. Okay, it's summation. Okay, and alpha is 5%. Okay, it's 5. And we have 3 pair, so n equals 3. Okay, so let's look at chi-square critical. Okay, according to the formula, we use right tail, so equal CHISQ inverse right tail. Okay, probability is 5%. Degree of freedom is n. Okay, I'm going to use. So degree of freedom is n minus 1. So this is our formula. So this is our formula. Okay, and so this is decision rule. Decision rule. Okay. So if our calculated value is higher than critical value, so if our calculated value is higher than critical value is F9, we reject. Otherwise, we accept. Okay. Obviously, we reject. Okay, because 7.34 is higher than 5.99. Okay. Okay. So let's look at p-value. Okay, p versus alpha. Okay, so we know alpha is 5%. So let's calculate p-value. Okay. CHISQ distribution by tail. So this is our chi-square value. Then we calculate degree of freedom is 3 minus 1 should be 2. Okay, 2. This is p-value. Okay, so this is our decision rule. Okay, if our p-value is less than alpha, we reject. Otherwise, we accept. In this case, we accept. Sorry, in this case, we reject. Okay, I'm going to show the formula. I think the most important formula is we calculate the summation of the error term square divided by expected value. Then we have two decision rules. One is we compare our chi-square value with critical value. If chi-square value is higher than critical value, we reject. Alternatively, we can calculate p-value, so p versus alpha. So if our p-value is less than alpha, we reject.
Shutterstock Music. Shutterstock Music.
Let's do the second in-class exercise. So type .ICE. So let's for the 49. Benford Law and the 23 receipts. The basic idea is we want to test the first digit of 23 receipts. Follow the Benford Law or not. Okay, so use up arrow key. We enter 49. Okay, enter 49. Okay. And if you are taking my course right now, you can type .explain 5, .explain 6 about my README file for the Benford Law. Okay. The first one, so let's get the data. Okay, in the trial of the state of Arizona versus Wayne James N. So let's get the data first. Okay. And so step 1, we search this phrase, we can get data. Okay. Copy the data to Excel. Then so this then we generate 1 to 9. We calculate the frequency. So this is Benford Law probability. It's log 10. For example, I equals 1. Its corresponding probability of 1 will be log 10. 2 divided by 1. So this is log 10. So it should be log 10, 2 over 1. So it's 30%. 30%. And step 3, find first digit is left. So left, this is string 1 function. Okay. Find the count of each digit. We use COUNTIF. So this is our familiar formula. For example, I equals 1. So this is count 1 for our data. So this is count 1 based on the Benford Law. Then again, so this is, we can treat it as error term, square. So this is count based on the Benford law. Okay. Summation of Vi, so V1, V2 up to V9 will be our chi-square. Okay. Then we calculate critical value. If the summation is less than critical value, we accept. Otherwise, we reject. Okay. So let's get the data first. Okay. Okay, so let's so from this web page, and so this is our data. You can read this description. Okay, this is our data. So let's copy the data to Excel. So we paste it here. We paste it here, and obviously it's not separated correctly. So we click data, and we click text to column. Okay, we choose first one, and it's got idea we use dollar signs. Okay, use dollar. Then you will see this procedure will separate them correctly. Finished. So I'll make it a little bit bigger. Okay, and then bigger. The instruction here. Okay, and the first one I use count. So I count everything here, and it becomes 22. Okay, so if you look, so let's make it a little bit wider. Okay, then you will see if it's number, it's aligned on the right hand side. So obviously something's wrong here. Okay, there are two decimal places. Actually, it doesn't matter. So we can use count A. We count A to count both alphabetic and numerical values of 23. Okay, we're going to use formula. One we use count, another use count A. So count A. Okay, the first one we get the first digit. Okay, so we use left. So this is we are going to get 1. So this is first digit. Okay, so this is 1. Okay, so 1, 2, 3, 4. We have 4 rows. 1, 2, 3, 4, 5, 6. Okay, we simply just copy. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, then we paste formula. Then we correct the first digit. We can manually count. So this is A, and this is A. So this is 7. So this is 7. Okay. Okay. The next one we are going to count the frequency. Okay. So let's type 1, 2. So let's 1, 2. Okay. And 1, 2 up to 9. Okay. To 9. So let's make this bigger. Okay, so this is our count, our frequency. Okay, so our frequency will be count if. Okay, so count if. So this is our range. Okay, so if our range equals to 1. So this is count if. I'm going to put the formula here. This is our formula. Okay. So count if, and so this is our range. Okay. Before we copy and paste, then we're going to log. Okay. So this is F4. And F4. Okay, and also we are going to this column. Okay, so this is C column. Okay, so this is $4. Okay, so next one I'm going to copy and paste. Okay, I don't have to column. Okay, so just copy and paste. And just double check. So this is summation. And 23. Again, I don't have to lock this C column. So this is not important. It's redundant. Okay, and so this is a Benford Law probability. Okay, we calculate the probability first, then we calculate count. Okay, so this is log 10. Okay, so this is I plus 1 divided by I. Then close it. So this is Benford Law probability. Okay. Again, so this is our count. So this is our count. So this is count B. Okay, so this is based on the B. You look at here. So the first one is this number. So this is count 1 minus corresponding count Benford Law. Okay. So Benford Law is the count will be probability times total. Again, we have to fix the total. Okay, I'm going to use formula text, should be formula. Formula, make a little bit bigger. Okay, so this is our probability times total. So we copy and paste. So we copy and paste. Okay, and so apply this formula. Apply this formula. So this is first one minus this first one from our targeted distribution square and square of the difference divided by this value. Okay, I put the value here. Okay, so I use n I minus n Benford Law I and power 2 divided by n Benford Law I. Okay, so this is our. Okay, I'll make it a little bit smaller. Okay, so this is equal. So this is first number minus first number from Benford Law. So square divided by target. Okay, so this is our value. Okay, I'm going to use should formula. Should formula. Again, so this formula is come from equation number 1. Okay, so this is n1, so I equals 1 from our data. So this I equals 1 from our expected. In this case, expectedly frequency from Benford Law. Okay, then we copy and paste. So we copy and paste. So finally, so this is our chi-square value. So it's a summation of this, all this value will be our chi-square. So 129. I'm going to use, show the formula. Okay, I'm going to copy the formula. Okay, so it's simply the summation of all this squared error divided by count of expected count. Okay. Okay, so let's calculate chi-square critical. Okay, so let's assume alpha equals 1% and n equals 9. Okay, so n equals 9 because we have 9 digits. Okay, so chi-square critical is CHISQ, IMV, we consider right hand. So probability is, okay, we're going to, okay, I enter point 0.01, I'm going to modify it. So this is 9 minus 1. Okay, I'm going to modify, so this is alpha is 0.01. Okay, so this is, let's see, H27. So I'm going to modify. So this is H27. Okay. So this is decision. This is what is called rule number 1. Okay. The rule number 1 is if our chi-square is higher than critical I-square, we reject, otherwise accept. Okay. Because we know 129 is higher than 130 is higher than 20, we reject. Okay. Formula text. So this is our decision rule. Okay. Okay. So this is then we calculate P versus alpha. Okay. We know alpha is 1%. Okay. So this is our P value. Okay. So P value we use chi-square inverse right hand side. Okay. Right hand side. Okay. Sorry, we use DRST, right hand right RT. Okay. So we enter our chi value, then we enter degree of freedom is 9 minus 1. Okay. So our P value is so close to 0. Okay. Then this is our decision rule. Okay. If our P value is less than alpha, we reject. Otherwise, we accept. Okay. We have the same result. Okay. Okay, I'm going to summarize this exercise. Okay. So we have 23 receipts. So we have 20 receipts. We want to test whether the first digit of these 23 receipts follow the Benford law. Okay. So step 1, and we calculate how many receipts. Okay. Step 2, we pick up the first digit. Okay. We use the, I'm going to show the formula here. Formula. Okay. So we use left. We use left, our string, our numerical values, and we choose the first digit. So left function. Okay. And then we use counterIf to count. What is frequency of 1? What is frequency of 2? What is frequency of 3? And continue this way. Okay. So next step, we calculate based on the probability. Log 10. So we base on the Benford law probability. Then we calculate Benford law's frequency. Okay, so eventually we compare this column, our observed frequency, with Benford law, our target frequency. Okay, then we apply this formula. First number minus first number squared divided by target number. Second number minus second number squared divided by second number, and continue this way. Okay, the summation will be our chi-square value. So this is our final result. Okay, then we compare with the critical value. So if our chi-square is higher than critical value, in this case it is true, then we reject. So our conclusion is these 23. The first digit of these 23 receipts do not follow the Benford law. Alternatively, we can calculate the p-value. Okay, and I'm going to show the formula. And the decision rule is if our p-value is less than critical value, we reject. Otherwise, we accept.